Assalamualaikum warahmatullahi wabarakatuh. Hello guys, we're from group 4 and we're gonna do a presentation, but before that we're gonna introduce ourselves. My name is Sarah. My name is Iluna Rayya.
My name is Alviandra, Arya, Saputra.
My name is Daffa, Khairy, Hakim.
Hi, my name is Iluna Rayya. So today I will present you how to solve this problem. So given that the function is u is 27 plus 6x minus 2x squared minus y squared, and then given that x plus y is 9, I'm gonna explain it to you using the lambda method. Okay, so when we apply the lambda function into this function, it's gonna be 27 plus 6x minus 2x squared minus y squared plus the lambda multipliers times 9 minus x minus. After we define the lambda function, we're gonna find the first order condition. It's like a first derivative. Y minus 4x minus the lambda. It has to be equal with 0. Here are the first derivative of each variable, and we have to find y. Since x plus y is 9, so y equal to 9 minus x.
Okay, so the next step is I'm gonna substitute the y equal to 9 minus x into the new equation that we get for the first derivative of x and derivatives of y. So after this, we got the new equation to find the value of x and the value of y.
After we got these two new equations, so we can calculate this to find the x. X is 4. Y is 9 minus x, so it's just...
Okay, so the value of x and y is 4 and 5.
Alright, so now I'm gonna present you how to solve the problem, page 60, first, number 6. We are given that z is 48 minus 4x squared minus... Okay guys, so we are given that 48 minus 4x squared minus 4xy minus 2y squared plus 16x plus 12y. Our goal is to find the maximum of z. We're gonna take partial of derivative z, x, so it's gonna be minus 8x minus 4y plus 16. And for the y, it's gonna be minus 4x minus 4y plus 12. Both equation, we have to make it equal to 0. Okay, so we can find the x and the y by subtract it, the first equation and the second one. So it's gonna be minus 8x minus 4y plus 16 minus 4x minus 4y plus 12. So this is the way how do we find the x and the y. For x plus 4 is 0, so x is 1. And the y, we will substitute the x into one of this question, and I have counted, and the y is 2. X and y is 1 and 2. After we find the x and y from the first partial of derivatives, we're gonna find the second partial derivative. The second derivative of x is minus 8. For the y is minus 4. After we got the second partial derivatives, we're gonna test the discriminant. Function of second derivatives multiplied by dy minus a function of x and y, derivative of x and y squared. So this is the formula. It's gonna be minus 8 multiplied by minus 4 minus 4 squared. Oh yeah, I forgot to write the xy derivative. So xy derivative is minus 4 also. And we got the discriminant is 16. So 16 is higher than 0. So the conclusion is the discriminant is bigger than 0, right? Function of derivatives, the x derivatives, the second derivatives of x is is lower than 0. So here are the conclusion. Since we already counted all. Okay, since the x is 1, the y is 2, so it's gonna be 48 minus 4 times 1 squared minus 4 times 1 and 2 minus 2 multiple 2 and times 2 squared plus 16 multiplied by 1 plus 12 multiplied by 2. So the result is gonna be 68. So we got the answer. First, the x and y are 1 and 2, and the type is maximum derivatives because the discriminant is higher than 0, and then the second derivatives is lower than 0, so it's maximum relatives, and the value of z is 68. So here are the final answer. That's all from me. Thank you.
Hey guys, my name is Putri Leoni, and in this video I will explain two mathematics questions. The first one is on page 93, number 4, and then the second one is page 94, number 26. But before that, I will write down the question. So the question is, px equal 12 minus px, py equal 15 minus qy, and tc equal qx times qy. So from this question, given that px is 12 minus px, and then py is 15 from here, and then tc is qx times qy. So now we will find the total revenue. So the total revenue is px times px plus py times qy. And then under this one is 12 minus qx times qx plus 15 times qy. And then 12 qy minus qx equal plus 15 qy. This one is the total revenue. And then the next one is the total cost. So the formula of the total cost is TC Qx times Qy. So the next one is the profit. And the profit formula is TR minus TC. TR minus TC. So it's gonna be 12Qx minus Qx equal plus 15 Qy, and then minus Qx times Qy. 12Qx minus Qx equal plus 15 Qy minus Qx times Qy. So next is lambda phi per 2Qy equal 15 minus Qx. 12 minus 2Qx minus Qy equal 0. This is the first one, and we can use this. And then the second one is 15 minus Qx equal 0. Yeah, this is the second one. Qx equal 15. So the next one is the substitute. The next one is substitute 2, 1. 12 minus 2 times 15 minus Qy equal Q, and then 12 minus 36 minus Qy equal 0, and then Qy equal minus 18. So the interpretate gonna be Qx is 15 and the Qy is minus 18. Okay. So the maximum profit occurs at Qx is 5 or Qx is 6. And then the Qy is 1. With the maximum profit of P is 45. So the final answer is the combination of quantities that maximize profit is Qx equal 15 or Qx equal 6. And the xy is 1. And with the maximum profit of P is 45. That's it for number 4, page 93. So given that utility function is u equal 27 plus 6xy minus 2x squared minus y squared. And then x plus y is 9. And from the constraint, the x plus y equal 9, and then y equal 9 minus x. And this is the budget constraint. So what we have to solve right now is the substitute into utility function, and the first one is y equal 9 minus x into u. U, this one is 27 plus 6x 9 minus x squared. What we have to do right now is expand each part. So it's 6x 9 minus x equal 54 because this times this, so it's 54x minus 6x squared, and then 9 minus x squared is equal 81 minus 18 plus x squared. So the next one is u equal 27 plus 54 x minus 6 x squared, and then 2x equal minus 81 minus 18x plus x squared, and then u is 27 plus 54x minus 6x squared minus 2x squared minus 81 plus 18x minus x squared. So the next one, the x is 54x plus 18x equal 72x, and then the x squared minus x squared minus 2x squared minus x squared equal 2 minus 9x squared. So the u is minus 54 plus 72x minus 9x squared. So u x is minus 9x squared plus 72x minus 54. X is minus 6 or 2a equal minus 72 per 2 times 9 equal minus 72 per minus 18. This is minus 9, by the way. Sorry if there's a mistake. And this is 72 per 18 is 4. So y is 9 minus x equal 9 minus 4. 9 minus 4 equal 9. So the values that maximize the utility is x is 4 and y is 5. This is the final answer. And that's it from me. Thank you so much. I'm Putri Leoni. Goodbye.
Okay, I will solve this problem from page 47 and number 4. Given that qx equal to 20 minus 2px minus py, and then the qy equal to 9 minus px minus 2py. We can use the lambda function. For the key x first. Key x. Lambda qx divided lambda p astagfirullah lambda p x equal to px minus 2 because this kita tutup ini jadi minus 2 we got from there and then lambda qx per lambda p y sama dengan minus 1 because there is no number in here and then for the py sama dengan lambda qy per lambda p x and then lambda qy per lambda py sama qy px is minus 1 ini minus 2 cross partial derivatives is the lambda qx per lambda py equal to minus 1 and then lambda qy per lambda px equal to minus 1 kalau sama-sama minus jadi barangnya komplementar. If the price increase, the demand will decrease. Okay, thank you. Okay, I will try to answer this question. This question from page 94 and from number 26. Given that u equal to 27 plus 6xy minus 2x square minus y square. X plus y equal to 9. Because we already know x plus y is 9, we can times the y with 9. So y equal to 9 minus x. And then I will try to find the function. U plus y plus x. Because we already know y equal to 9 minus x, we change y with 9 minus x. Minus x minus 2x minus x. Dengan x kuadrat minus 2x kuadrat minus 81 minus plus x kuadrat and then plus 18 X kuadrat. And then you minus 9x kuadrat plus 72x minus 54. So, kita udah nemuin nilai UX-nya. Okay, now we use the determinant function or turunan with the U accent equal to minus x plus 2x. We got the U accent. We can use the zero function or persamaan nol. Minus 18 x plus 22 x equal to 0. Then 18 x equal to 72 x. X dengan 72 divided by 18. X is 4. We got the x. And then, as we know, we got the y equal to 9 minus x. So, y is 9 minus 4 equal to 5. And we got the y. Okay, that's how we do to find the x and y. Okay.
So in page 94, number 26, we were given u equals 27 plus 6xy minus 2x squared minus y squared. And the budget constraint is x plus y equals 9. So the question is, what values of x and y maximizes u? So we have to maximize u under the condition that the total of x plus y equals 9. We are going to use the lambda method. So first, L equals 27 plus 6xy minus 2x squared minus y squared plus lambda with 9 minus x minus y. And then we take partial derivation. Okay, so the first derivative is x. So partial L with respect to lambda equals 6y minus 4x plus lambda equals 0. So this is equation 1. And then the second equation is derivative with respect to y. So the same as before. this equals 6x minus 2y minus lambda equals 0. And this is the equation number 2. This is equation number 2. And then we do derivative respect to lambda. Equals 0. So this is the equation. This is the budget rule. And then take the equation 1 and equation 2 and set the right sides equal to each other. So I will erase this. Alright, so we are going to take equation 1 and 2 and set the right sides equal to each other. So first, it's going to be lambda equals 6y minus 4x, and the second one, second equation is 6x minus 4y. So we're gonna make it like this: 6y minus 4x equals 6x minus 4y. And then we move it to one side, so it becomes 6y plus 2y equals 6x plus 4x. And then we add it. We add all of it. So 6 plus 2y equals 8y. 6x plus 4x equals 10x. And then we plug this to equation 3. Okay, so and then x plus y equals 9. X plus y equals 9. And then we make it x. X equals 9. And then 9 for 4x equals 4x equals 9. And then x equals 4. So this is the x value. So next, we need to find the y value. So y equals 5 times 4 equals 5. And so the final answer is x equals 4 and y equals 5. Okay, so there is actually an extra. So as we know, x equals 4 and y is 5. So this is an extra function. So the maximum utility, as we know, x is 4, y is 5. So what's the maximum utility? So what is the maximum utility? So u equals 27 plus 6 times. So the maximum utility, it is u equals 27 plus 6. So this is x is 4, and then we multiply it. Also this is y, so y is 5, and then minus 2 times 4, because x is 4 square, minus 5 square, because this is y, and then so 27 plus 6 times 4 times 5, 120, and then minus times 4, 32, and then minus 25. So overall, it is 27 plus it is 90. Okay, so now I'm going to do the Nicholson chapter 11, number 5, page 356 and 357. So first, the total revenue that we were given is that TR equals minus 0.2 Q square plus 900 Q, and then the TC, we got TC equals 0.03 Q square plus 6,000. So Q is the number of computers. So the questions are, first we need to find the marginal revenue. So first, marginal revenue and MC. And then we need to use them to find Q, that gives maximum profit. So, and then the third part is we need to find the maximum profit. Okay, so first we need to find marginal revenue. Marginal revenue is the derivative of TR. So TR equals minus 0.2 Q square plus 900 Q, and then we take the derivative with respect to Q. MR equals D TR equals minus 0.4 Q plus 900. So, and then we need to find marginal cost, which is the derivative of TC. So since the TC is right here, so MC is D TC DQ equals 0.09 Q square minus 0.4 Q. Okay, and then next we need to set the marginal revenue equal to marginal cost to find the quantity for maximum profit. So we need to set the two equations equal. So minus 0.4 Q plus 900 equals 0.09 Q square minus 0.4 Q. So we need to cancel out the minus 0.4 Q from both sides. So it will look like something like this. 0.09 Q square. Okay. So now we divide both sides by 0.09. So it's Q square 900 and 0.09 equals 10,000. So now we take the square root. So there's no more number there. Then 10,000 equals 100. So maximum profit happens when Q equals 100 computers. And next, we find maximum profit. So we need to use the original TR and TC equations. So the TR is, so we need to find TR when Q equals 100. So TR equals minus 0.2 square plus 900 and 100. So then minus 0.2. So 100 square is 10,000 plus 900 times 100 is 90,000. And then we multiply minus 0.2 with the 10,000, so it is minus 2,000. And then we plus 90,000. So minus 2,000 plus 90,000 equals 88,000. So this is the TR in finding maximum profit, and then the TC. So the TC equals 0.03 100, okay, minus 0.2 100 plus 6,000, and then 0.03, since 100 times 100 and times 100 is 1 million. And then minus 0.2 times 1, 0, 0, 0, 0, plus 6,000. So 0.03 times 1 million is 3,000 minus 2,000, yes, 2,000, plus 6,000, which equals to 7,000. So next we need to find profit. So profit, the function of profit is TR minus TC. So 88,000 minus 7,000 equals 81,000. So the final answers are, first, the marginal revenue. So the marginal revenue is 0.4Q plus 900, and the marginal cost is 0.09Q squared minus 0.4Q, and the quantity for max profit is right here, 100, and then the maximum profit is $81,000, or whatever the currency is. So that's it from me. Thank you.
Thank you.